Hi guys, so this is Debarshi again, and today I am going to try something new. My cousin has a calculus problem that she wants me to solve, so without further ado, let's get right to it. So here we have this interesting sign that we call an integral, and we're going to take the integral of 8y to the 4 plus 4y squared plus 1 squared times y cubed plus 2y dy. And there's a comma after this, and that's because this problem actually comes with a u value, but you can actually solve this problem without a u value, and I'm going to teach you guys how to do it. So right off the bat, we could tell that there are several elements to this equation over here. Inside the integral, we have the coefficient 8, and we have the phrase y to the 4 plus 4y squared plus 1, and we also have y cubed plus 2y dy. Well, there are several ways that we could try going about this, but today specifically we're going to use something called U-Substitution. We are going to denote part of this integral as u, and after denoting part of this integral as u, we're going to try to substitute in for the other part of this integral by getting something called du, or the derivative of u. So let's start. So here we have several values. We have y to the 4 plus 4y squared plus 1, and we have y cubed plus 2y. Now, one of the things that comes right away to me, and it may or may not to some of you guys, is that this y to the cubed is exactly 1 less than y to the 4th right here. And this 2y is a constant multiplied by a variable. So what happens if we did this? U equals y to the 4th plus 4y squared plus 1. Okay, so now we have to find the derivative of u, also known as du. And in order to do that, we're just going to use simple differentiation rules. In this case, we're going to use something called the power rule, in which we're going to take the 4 and bring it down. So this is going to become 4y cubed plus 8y and this plus 1 is going to become a 0 because the derivative of a constant is 0. And in addition to all of this, we can actually put dy, because when we're taking a derivative, we also get the derivative of the variable, dy. So, do we have 4y cubed plus 8y anywhere in this equation? No, we don't. So what happens now? I mean, it seems like we're stuck. But if you look at the equation carefully, if you look at this integral carefully, you'll realize that there's y to the cubed and that there's 2y. This is 4y cubed, and this is 8y. Do we start seeing a pattern over here? Anyone see it yet? This value right here, 4y cubed plus 8y, is actually 4 times y cubed plus 2y. So what we can do now is we could say that du equals 4 times y cubed plus 2y. dy. Well, that doesn't help. I mean, we've just got the 4 out. So now what do? We have to get it out of this entire equation and then substitute in for y cubed plus 2y. Well, that's actually a pretty simple thing to do. All you got to show is that du over 4 equals y cubed plus 2y. If I could write better, that would be nice. Y cubed plus 2y dy. Okay, so now we've got that du over 4 equals y cubed plus 2y dy. So how are we going to solve this integral? It's actually pretty simple. So as you can see, we have a constant over here. We call it 8. And all constants can go outside of the integral right here. And then we can multiply this constant by 1/4 because when we divide du by 4, we essentially put 1/4 outside of the integral. So 8 times 1/4, what is that going to be? It's going to give you 2. So after that, let's just cut this out and replace it with the 2. And then what we're going to do is we're going to take what we substituted in for u, y to the 4th plus 4y squared plus 1, and we're going to call it u. And as you'll see, we substituted du, or well, du over 4 as y cubed plus 2y dy. Now don't forget this square over here. We have to square u, so u squared okay, that's not what I meant to do. So we get u squared plus dy, plus d, u squared times du, because du is y cubed plus 2y. And this integral should be pretty simple to most calculus students. So now all we're going to get is 2 times u cubed over 3 plus c, which is a constant, by the way. Remember, when we're doing indefinite integrals, we get a constant, 2, outside of the normal outside of the normal integrated values. So we got that. So this ends up becoming 2u cubed over 3 plus c, because c is a constant. We don't really call it 2c or anything. It's still a constant no matter what. It's kind of like multiplying by infinity. If you think about it, you'll get infinity. 2u cubed over 3 plus c. Okay, so now we have 2u cubed over 3 plus c. Are we done? No, we're not. And the reason is because we substituted u for y to the 4 plus 4y squared plus 1. Now, the result of this integral has to be in terms of y, because we're given this integral in terms of y. So in order to do that, all we gotta do is take this u value right here and substitute it back in. So the value of this integral undo pencil, 8y to the power 4 plus 4y squared plus 1 squared y cubed plus 2y dy. So this ends up becoming 2u or y to the 4 plus 4y squared plus 1 cubed, because we have a 3 up here, so don't forget to cube it, over 3 plus c. This is your answer. For most classes, you're not going to have to simplify this. If you input this into Wolfram Alpha, input this integral into Wolfram Alpha, chances are you might get a simplified version of it, but in most classes, you won't have to simplify this, honestly. This should be the correct answer. If I am wrong, please don't hesitate to contact me or comment on my YouTube posts. Again, this is my first calculus video. It isn't really even much of a tutorial. It's more of a question my cousin asked me that I'm helping her out with, and I just thought for entertainment purposes and enlightenment to others, I could potentially post this video on my YouTube channel. Anyways, please don't hesitate to subscribe or comment, and I'll see you next time.